Now let's do some work with radicals 20-1s. We've done talk about this whole idea of simplifying things. Well, now let's do some calculations. So page 6, we're going to add and subtract radicals. Well, before we get started, if I have two radicals, you don't have to take this down, but 3 root 7 plus 2 root 3. Well, the radical itself is kind of like a variable. This is saying I have 3 root 7s and I have 2 root 3s. Well, root 7s and root 3s, they're not the same thing. Root 7 has a value, root 3 has a value, so I can't say that 3 root 7s and 2 root 3s, they go together, because root 7 is a different value than root 3. It's kind of like saying if I had 3 x's and I want to add 2 y's to it. Well, polynomials, we can't combine x's and y's because they're not the same. What will go together here? Well, a 3x will go together with a 2x. 3x's and 2x's is 5x's. So what would go together with a 3 root 7? Yeah, a 2 root 7. 3 root 7s and 2 root 7s means we have a total of 5 root 7s. So when we add and subtract radicals, it's kind of like working with polynomials in that we need like terms. And that's what adding and subtracting radicals really comes down to. So page 6, 3 root 5, subtract 7 root 5. The first thing we want to do when we have a question that asks us to add or subtract is we want to identify the radicals that are like. Identical radicands. So we can see in this case, root 5 and root 5, we have 3 root 5s and we have negative 7 root 5s. So what does that mean we have? Well, just like with polynomials, we're going to add and subtract the coefficients. 3 root 5s and negative 7 root 5s is like having negative 4 root 5s. And if you punched into your calculator 3 root 5 minus 7 root 5 and hit equals, you're going to see that its value will be the same as negative 4 root 5. So let's take a look at the next one. 6 root 7 minus 3 root 2 plus 5 root 7 plus root 2. Well, first thing I want to just show is don't forget that this has a coefficient of 1 if that helps you. 1 root 2, same thing. So identify the like radicals, or radicals, means the ones with the same radicals. Root 7s can go together, and root 2s can go together. 6 root 7s along with 5 root 7s, well, that means we have a total of 11 root 7s. Negative 3 root 2s and positive 1 root 2s means we have negative 2 root 2s. And there's adding and subtracting radicals. Simplest to start with, gonna get a little trickier, a little bit more work, but it's just like working with polynomials. We need the like radicals so we can combine those together. Well, here's where it starts to become more work, because now we have root 8 plus root 18. Identify the like radicals is step 1. But we don't have like radicals. So we can't do step 2, add and subtract coefficients. However, I'm hoping some of you are looking at that saying, yeah, but I can. So take a second, look at it, and what can you do? Well, let's add a step for number 1, is let's simplify the radicals before identifying. Make sure the radicals are in simplest form. Make sure that our radicands are as small as possible, because if our radicands are as small as possible, we might have like radicals when we didn't even know it. So 8, 4 times 2, root out the 4. 18, 9 times 2, root out the 9. We're left with 2 root 2 because the 4 gets rooted out, plus 3 root 2 because the 9 gets rooted out. Once we've simplified, well, now we hopefully see, if we've done it correctly, that we have like radicals. And now I can just add and subtract the coefficients. 2 root 2's plus 3 root 2's means I have 5 root 2's or 5 root 2 as the sum when I combine the radicals. So all these steps, this is actually a 10C step. This is a new step, but it totally builds on that idea of 10C's of combining like terms. So not new information, just new in how we put it together. So give this one a try. Stop the video, simplify it, see what you come up with. So here we go, 12. 4 times 3, we can root out the 4. 50. 25 times 2, we can root out the 25. Don't forget you have a coefficient of 1. 75. 25 times 3, we can root out the 25. Coefficient -1. And 32 is a 16 times 2, so we can root out the 16. All of these radicals simplify. Hopefully that'll give us some like radicals after we've simplified. When we root out the 4, that means it's becoming a 2. So 2 times 2 leaves us with a 4 root 3. 25 gets rooted out. 25, when it's rooted out, is a 5. So we have to multiply 1 by 5, which now leaves us with a 5 root 2. 25, the 75 is 25 times 3. 25 roots out, becomes a 5. Make sure you multiply the -1 by 5, which is a -5 root 3. And the last one, 16 is going to root out. Root of 16 is 4, so we have to make sure that that coefficient, -6, multiplies by 4, which is a -24, but still with the root 2. If you can simplify, you're off to the horses, off to the races, because we can now, after simplifying, see that we have some like radicals that can be combined. 4 root 3's and -5 root 3's is a -1 or just -root 3. 5 root 2 and -24 root 2 leaves us with -19 root 2. There's the combination of those 4 radicals being put together. Last one, or there's a couple more actually, we get a little uglier, so bear with me, sorry. Root 50 plus cube root 250. So here we go. 50, 25 times 2. Root out the 25, leaves us with 5 root 2. Cube root of 250. Well, that's going to be 125 times 2. We can cube root out 125, which leaves us with 5 cube root 2. So there's our first step. We simplified the radicals. Which of these two go together? None of them. They are not like radicals. Why not? Because they're different degrees. So if you have different degrees, sorry, not degrees, indexes, I apologize. They are a different index. And different index don't combine together. Just like with polynomials, x and x squared, they are not like. We don't combine those, same thing. The root of 2 is a value, and cube root of 2 is a different value. So I don't have 5 of that and 5 of the same thing. I can't combine them. That's as far as that question can go. No combining because we don't have like radicals because of different indexes. So now, here we go. 3 more to do. You're going to have to find some paper to add these on. because we need to be able to look at this with the exponents, or sorry, with the variables, making sure our exponents are the same. So write that one down and we'll walk through it. Again, we still want to simplify. 4m, I can root out 4 because the square root of 4 is a 2, and m I can't root anything out because m, I can't multiply something by itself to get an m. So if I root out the 4, I'm going to be multiplying by a 2, and I'll have 8 root m. If it helps, there's a coefficient of 1 out front. M by itself can't root out an m because nothing times itself gives me m, so I still just have a negative root m. And then 2 root 9m. Well, what's nice here is that 9 is a perfect square, so I can root it out. And when I root 9, I get 3, so I'm left with 6 root m. Even though there's variables in this case, doesn't really come into play too much. 8 root m, negative 1 root m, and 6 root m, they're all root m terms, so I can add or subtract the coefficients. 8 and negative 1 is 7. 7 and 6 is 13 root m. There's my simplified form. Now you do have some variables under the root signs. Simplify. Give it a try. See what you come up with, and then we'll talk. So here we go. 27 is going to be 9 times 3, but also x can be an x squared. So 9x squared will root out, and I'll still have a 3x. Because 9x squared and 3x is still 27x cubed, but the 9x squared will root out, and I'll be multiplying by 3x. So that leaves 3 times 5 is 15, x times x. I now have a 15x squared with a 3x for the radicand, because 27x cubed broke down into those two, and 9x squared can be rooted out as a 3x. Same thing with this second one now. 300x to the 5. Well, 300, 100, and x to the 4. 300 becomes 100 times 3. I can root out the 100. And x5, sorry about that, x to the 5 can become an x4 and an x1. So this 300x to the 5, 100x4 can be rooted out. 100 square rooted is a 10. x4 square rooted is an x squared. And I still have times 3x1. So 3 times 10x squared leaves me with a negative, that leaves me down here with a negative 30x squared, and I still have the root 3x. Simplifying becomes more involved because of the variables, but process doesn't change. Now I have both radicals are the same, so I have like radicals. So 15x squared minus 30x squared, and all of that is to root 3x. So there's the two coefficients that need to be combined with the like radicals. 15x squared minus 30x squared is negative 15x squared root 3x. Lots of little things to watch as soon as we have to start rooting with the variables. All right. Next one. Again, lots going on. Give it a try, and then we'll take it up. So what we have to be careful of with this one is we do have cube root in 2 cases and a square root. Don't say it can't be done yet. Let's do the work. Simplify your radicals. Well, cube roots. So now I need my 16x to the 5 to be a cube root. Well, that would be an 8x cubed. I can cube root 8, which is 2, and I can cube root x cubed, which is x. So this is going to be times 2x when I root that out. But it leaves me with a 2x squared still. So that's what the 16x to the 5 became. 8x cubed roots out to become a 2x. When I multiply those two, I'm left with 10x cubed, cube root 2x squared. Now I need to do the same thing with my second mixed radical. Well, 54x to the 8. Well, it's a cube root. So 54 could be thought of as 27 and a 2. What's cube rootable in terms of a variable? Well, that would be an x6. And that would leave me with an x squared. So this 54x to the 8 could be broken down to 27x6 times 2x squared. 27x6 will root out, cube root out, and I'll be multiplying by a 3x squared because that's the cube root of 27x to the 6. When I multiply those two things together, I'll have 9x cubed. 3 times 3 is 9. x1 times x squared is x cubed. But I still have under the root sign that 2x squared. And I'll finish with square rooting 50x squared. Well, 25x squared will root out because it's a square root, but I would still have times 2. So 25x squared roots out to become 5x. So negative 1 times 5x, which is a negative 5x. And I still have root 2 under the sign. And at that point, even though we have cube roots for 2 of them and a square root for the third, we can see that our cube roots, I forgot my cube root symbol there, yikes, caught it though. I have cube root 2x squared and a cube root 2x squared, so like terms, 10x cubed plus 9x cubed, 19x cubed with the cube root 2x squared as my radical there. And I still have this last term, which is just going to be standalone, doesn't combine with anything. So there's what we end up with. 19x cubed, cube root 2x squared, minus 5x root 2. Lots of little steps with this simplifying especially. Hopefully you did the practice converting radicals, entire radicals to mixed radicals with the exponents, because that's just practice. So there's your assignment, page 278. Give it a try. There's not a ton of questions. This is not yet, I don't think, too complicated. Gets a little confusing with all the variables, but otherwise the process isn't that bad. Practice, stay on top of it, and have a great day.